Hello, I'm JW. This time we've got some more things to look at, and these have been sent in by James McBride. And what these are essentially is a 3-pole circuit breaker on one side there, and a RCD on the other side. And it's a 3-pole RCD, but it also has the neutral connection, which is this black lead, so of course it can monitor the current in all of the conductors. And these are 3-phase, obviously, because of course 3 poles there. And apparently these came out of a lighting installation, and I've actually got 2 of these, both identical, and these are actually broken. And the problem is that they're in the off position here, and if you try and switch them on, as you see, it just won't actually stay in the on position. And of course the same thing with the RCD as well. So one or both of these has failed in some way inside, so we're going to take these apart, have a look inside, see how they're made, and also hopefully see what the broken part is. So here is the item, and this is actually 2 completely separate things. We've got on the left here the circuit breaker. This is a 3-pole designed for 3-phase use, and it's actually a 32 amp, so see the 32 there, and it's a type D, and that's not normally used for a lot of things. It's generally where you've got a very large surge when whatever it's controlling is switched on. And this is actually a separate piece from this piece on the right. This is actually a module which can be added on. And this is an RCD, and this is one that reacts to a current imbalance, so in other words current's going somewhere that it shouldn't be, whereas the circuit breaker here just reacts to an overload or a short circuit. And these things are actually detachable. There's a little orange piece here at the bottom, so we can undo this, and then the whole thing will just clip in at the top there, little tab there, so just lift that over and then we can just remove it. Now of course these are normally tightened up onto the wires here, just loosen those before. So this is just a circuit breaker, and normally it would be the power going in at the top with the 3 phases, and then the circuit wiring at the bottom here to whatever you're controlling, and that can be used as a separate item. But in this case we've got this additional module here, which is an RCD, so that goes in the bottom here, got the 3 wires, they go up inside, and again that just clips together like that. And then the power will go in the top out of here through the RCD and then come out the bottom on these terminals here. And we've got this lead which is actually for the neutral, because although the circuit breaker doesn't switch the neutral and the RCD doesn't actually switch anything on its own, we do need this so that it can actually sense the current in all 3 phases and the neutral as well. So wiring for this will be 3 phases in here, this will be the neutral connection coming in, and then you've got your circuit wire come out here, so neutral, and again the 3 phases coming out. And again we've just got the normal terminals there on the bottom. Now this is actually broken just as the other one, and the fault is that it won't switch on, and see there it just won't stay in the on position, and likewise over here. And if we take the thing apart again, we can see that this on its own does work perfectly normally, and this is actually what's broken. And the way that these work is that this is the switching device, so that's where all the actual switching is contained. This doesn't have any switching at all, and what it does is when this trips, this little pin on the side here goes into this hole here, so because this won't reset, then it means neither will this one. And the deal is that when it's in the on position like that, this pin will go in there, and if it moves forward and presses on that piece of plastic, that will cause the thing to trip. So it's just a question of that happening, and it's a very slight pressure there, it just has to move that a tiny fraction and that will cause it to trip. And the fault is in this one, as it won't obviously lock in the on position, and you've got this pin here which is permanently forward, so essentially it's preventing that from resetting. What should happen is when it's turned off, that pin will go back and it will actually stay back there, and then of course when this trips that moves forward. So that's pretty much how they work. There's a little diagram there as well which shows you the same. So we'll take both of these apart, starting with this one, and actually see how these things work and what's inside. Now this one should be just 3 separate actual modules here, so just basically the same as the single phase one, but just 3 fixed together, and again just the solid bar put across the front, so they're all basically connected together there. Now I've already drilled out the fixings on the side, so we should be able to pry this open and have a look inside. So there's a look inside of the circuit breaker. and it's fairly typical to ones that we've seen before. I've done another video on other circuit breakers previously, and it's pretty typical. I mean, we've got the two terminals at the bottom and the top here, so fairly large there with the screw to secure the wire. Same kind of deal at the top, that will just come in at the top there. And then inside we've got the magnetic trip coil, which is this one here. This is a fairly small coil because, bearing in mind, this is a 32 amp breaker, and obviously the smaller number of turns requires you need more current to actually trip the thing. Arc chamber here, and the contacts say down the bottom here, so if any arc occurs when the contacts open, it's diverted up in here, and then these plates serve to sort of break the arc up into small pieces so it can't actually continue. And then the thermal element is at the bottom here on this strip, so essentially as the current passes through, this will heat up. When it gets to a certain point, if it's been overloaded, say on the circuit, then this will heat up enough and it will bend and then obviously trip the mechanism. So fairly standard deal inside there, and I say it's pretty much the same as we've seen in the other circuit breaker in the other videos which I've done already. See on the lid here there's a bit of burning and discoloration, and that'll be from where this is obviously opened in the past. But fairly common to see that sort of thing. I mean, based on the first use, it's going to have some amount of arcing, so a bit of discoloration is pretty much what you'd expect. But other than that, it seems to be in reasonable condition there, so don't think that's any problem, certainly within that part. Now this is the RCD which has failed, so it's permanently in the off position, it just won't reset. And interesting enough, the other one is pretty much the same. If we just take these apart here, just bend that, and yeah, it's the same thing. So the actual circuit breaker is still operational, but it's the RCD which has basically failed in the open position. Again, the same deal with the pin that goes through from this side to the circuit breaker to trip that. So we'll open this one as well. This doesn't have any screws or rivets, it just appears to be a clip together kind of thing, so shouldn't be too bad to get into. So just seems to have these tabs here, so I'll just basically break those off, and that should release the actual cover from the device. Now it's fairly likely a load of stuff will just spring out here, so let's attempt to be a bit careful with that. I just need to cut through the label as well. Right, so the back is just basic plastic moulding. I've actually got this resistor which was basically just slotted into that little assembly there, and that's actually for the test button on the front. So of course when you press the test button, it just makes basically a bypass through that resistor, causes an imbalance there, and then of course that should trip the device. So it's just a little post there to hold that into position. One end is wired in obviously to the actual device, and then the other contact is actually here on this little spring piece, so that would just press against the top there when it's in position, and then it goes through to the button on the front, which we'll hopefully be able to have a look at in a moment. So inside then we've got what is basically the sort of old style RCD, and no electronics in this particular one. Let's just see if we can extract it from the casing fully. So there we have it, just managed to remove that from the casing. So these are the screw terminals at the bottom where of course the wiring will connect. We've got all four conductors here, so neutral in the three phases, and of course those go through this ferrite or similar core here, and then again we've got those coming out the top there, so your three phases here, and then of course the neutral on this flying lead for separate connection. So it's probably some kind of a ferrite core there, and we'll see we've got these very thin wires coming off, which will be the sense wires here, and a little tiny circuit board just down in there. I'm going to have to actually cut those wires just to extract it from the case there. So here's the core, so I've basically got the wires coming through from the bottom. This brown is some kind of plastic insulation on those, so they'll go through the middle, come out at the top, and then they basically loop around the outside. So I've got these bits here where they've also been put through and then just crimped or soldered or whatever to join them. And again, all four go through there, and look at the bottom once again, and then out the top, and of course to the other terminals here. So it's basically just one turn for each of those four conductors. This white wire here is the test resistor, which we saw previously, and that's basically attached to this particular one here, which will be one of the phases. And again, when that's turned on, it will just create an imbalance within this core here, so then that can be detected by the circuit board, which is in the other half. And we've got these very thin wires here, which will come off from this core, so it's probably a winding inside there or something, so we can also detect that the current has changed. And essentially all this will look for is any kind of current flow, because of course when it's in normal operation the current on all four should basically cancel out to 0. So in the bottom here we've just got the little circuit board there, and of course I have very fine wires coming across from the coil, and we can see down at the bottom there there's two more things there which just connect into the side of that. So here's the little circuit board there. Again, not a whole lot on here, it's just purely a passive type of circuit. So we've got say just a couple of resistors and things here, what could well be a couple of diodes there, and that is pretty much all we've got. So a very simple arrangement. So this is an older design type of thing, so you don't have any kind of electronic amplifiers or microcontrollers or whatever in this, unlike on some of the new ones. So a very simple little device there. So again, these are our wires from the core, and then the two here, of course, be the output going into the bottom of this. Now here's the actual mechanical part here, and this is all built into the front case. So we've got inside here the part for the test button, which is on the front there. That's one you would just press to connect that resistor in, and that's a very simple arrangement. So if we press the button, so it's just moving up that wire at the bottom to make a contact here. And you see that then comes up here around there and it goes across to the back, so that will actually contact on the back of the casing we saw there on that post. That's where the resistor would be installed. So all that's doing is just connecting a circuit there temporarily and passing a current through that resistor. So this is the actual mechanism of the RCD. Notice it doesn't have any switching of its own, it's purely a case just to hold the various contacts in position. So this is pretty much all that's actually going to happen. So in the on position, and that would be up there, normally you're not going to get any current from the three wires here from this coil, because all of the current on four of these will basically add up to 0, so there's no net magnetic field here. But when some fault occurs, some current's going to flow elsewhere and not come back through this, so you're going to get a magnetic field here. It's going to be picked up by these very fine wires, and presumably probably thousands of turns inside, via the little circuit board, which say has very little on it other than a couple of resistors and capacitors there. Voltage comes up on these two pins which go in here. This will energise this small coil inside, and then when that's energised, we see that little tiny button thing on the top that will push upwards against this piece here, and then when that's pushed upwards, then it trips to the off position. So that's on, and it's a very slight amount of pressure required. It just trips down to the off position. And the only switching, of course, is done in the circuit breaker, which is attached to the side of this, and that's via this pin here on the side. So in one position it's at the back there, and then when it's in the off position that just moves forward. And as we saw with the circuit breaker before, that just moves forward and presses on the piece on that one, and it's enough to cause that to trip as well. This is the little coil here, and you see that's just the pin that pops out when the actual thing is energised, so it's a little spring-loaded bit there, and it will just that might have been what was actually sticking. Actually, it's a bit sticky there. So just open this, have a quick look inside. So there we have it inside. So just simply a little tiny coil, so maybe thousands of turns probably there of super fine wire, and then the little piece on the top here, which of course would be either repelled or attracted depending on the exact configuration. So by default it's sprung in, so it's probably going to repel that. Yeah, there's a bit of residual magnetism there on top of the coil, so yeah, it's just about enough to hold it in that position. That may be what the actual failure was, because if that had actually stuck in the, or wouldn't actually go back down, yeah, it seems to be doing it better now, but if that had actually stuck in the up position, it would permanently press the plunger out, and that of course would trip the other mechanism. But yeah, there does seem to be a little bit of magnetism on the top of there, but it's not all that good. So that may be the bit that had failed, but again, it's obviously a little tiny coil, so not a lot else to say about that. Now I will open this as well, just because we can might as well have a look at the whole thing. It's probably going to be just a set of these wound round and round inside many hundreds or thousands of times. So here's the coil, and I've just basically cut those there to fold them back out of the way. These are solid copper, and they've got some kind of plastic or similar coating over the top. Would expect these to be a fairly high temperature rating type of material, so maybe Teflon or something similar, but nevertheless it's very well fitted over the conductors there, not the sort of thing that's going to just fall off, so it's definitely not just your standard PVC insulation, it's something considerably more robust. So this hopefully will come apart, and just go in and should be able to peel this tape away, and then we may be able to split the thing in half. So there's the inside of that, so it's just two halves of a plastic casing there, and we can see inside the many hundreds or maybe even thousands of turns of those fine wires coming in from the outside. That's with the whole covering gone, and just see what's actually underneath the wires. So these are ridiculously fine, which pretty much what you expect, because of course you need a huge number of turns, because the current imbalance we're talking about here is extremely small, 30 milliamps in the case of this particular one. So underneath there it looks like we've just got a plastic core there with yet more tape on the top. So as you see, huge amounts of this extremely thin wire, and then inside we've got another split kind of plastic covering. Let's see what we have in there. So it's some kind of core, and you see it's sort of laminated across the width there, so it's made out of a number of rings or similar, all fixed together. It might even just be a big spiral of something, because there is actually a edge there. It's not coming undone, but I don't expect it to be permanently glued together. So it's either individual rings, or more likely it's just a strip of metal that's been spiraled around and round many times with some kind of adhesive or some kind of separator between the layers, and that just happens to be the end of it. And magnet readily sticks to that, so it's some kind of ferrous material, iron, steel or something in that general area. So pretty much as expected then, some kind of metal core there, plastic covering, sense wires over the top, many hundreds of turns. Not quite sure why there were actually 3 of those, but nevertheless there's obviously some thinking behind doing that. And then a little tiny circuit board, and basically another little magnetic coil at the other end to trip the mechanical mechanism. So that's it for this time, and if you want to send in anything yourself, then links are on the description to this video, or of course in that sort of card thing at the top corner. And the failure nose is almost certainly going to be this microscopic little coil, which seems to have the function of it spring-loaded piece there, which is what obviously trips the mechanism when the plunger is pressed out. And of course it's intended to basically stick in the basically closed position there until this is energized, which will repel the coil and cause it to spring up, but it doesn't seem to stick down all that reliably. So it's pretty much got to be that, because the rest of it is only a piece of plastic and some springs, all of which seem to work as described. So whole device ruined just because of that microscopic little coil there. So that's it for this time, and until next time, thanks for watching.